I'm Augustine Von Trapp, and this is the final presentation for FSE 100. Our project is the remote rescue drones, and I'll just jump right into it. So our problem statement is to solve the issue of rural communities' access to quality disaster response. Our target customers are rural community leaders and communities that lack emergency response infrastructure. The current issue with the market right now is that disaster relief is expensive to invest in, and if you rely on state response, it can be delayed for a very long time. So our solution is we propose a system of pretty inexpensive drones that work together to provide a timely and inexpensive alternative to traditional disaster relief. And with that, I'll hand it over to Dawson.
Thank you, I'm Dawson. Our first design is the FlyEye, which is specifically used for reconnaissance and surveying areas. The second solution is the FlyPhone, which is used to communicate to the victims. The third is the FlyDrop, which is to deliver crucial supplies. And then the fourth one is an extraction drone called the FlyHigh to get people out of inaccessible areas. We'll pass it on to the FlyEye.
Hi, my name is Blanca Ibarra, and this is the drone I designed. It uses two motors, an IR sensor, and a remote for navigation, and a distance sensor as well to ensure the avoidance of objects as it searches. I'm going to go ahead and pass it over to the flight phone.
Hi, my name is Fee. I designed the FlyPhone. The FlyPhone uses four motors to take off, and it's used to provide communication. Within it, we have a winch that raises and lowers a microphone to a victim so they can communicate. There's also a push to talk button on there as well. And then in the actual body of the drone, there's a speaker, and the operators can use it to relay information. Then next we have the FlyDrop.
Yeah, so the FlyDrop uses a camera for navigation and a basic release mechanism to pick up and release supplies to its victims. I'll go ahead and pass it off to the FlyHigh.
Great, so the FlyHigh is used for extraction. The circuitry here represents everything needed for the ultrasonic distance sensor, the servo motor, the force sensor, and the motor that represents the winch to deploy a balloon to provide extra lift when this is used to lift things that a group of people on their own can't lift. And I'll pass it off to Blanca to talk about the collaboration of the drones.
Okay, this is just a little example of how our drones work together. So the search and rescue drone or FlyEye would go first. Once it finds people, it'll send in the FlyPhone. The FlyPhone will communicate with the people, find out their needs. If they just need water, food supply, they'll send in the FlyDrop. If they need immediate rescue, they'll call in the FlyHigh.
As opposed to traditional disaster relief, our solution is designed to take effect in minutes, not days. It's also designed to be financially accessible. And then it's also designed to be easy to operate, so it won't take a lot of training for the operators. Benchmarking and value added. There are a couple other companies that also do the same thing. They specialize in drones. So the first two we have here, Zipline and Wingcopter. These two companies, one's based in California, the other in Germany. They're there to provide medical supplies and vaccines. And then we have SenseFly. It's a company under AG Eagle, and they use drones to map topography after natural disasters, so relief workers know where they're going. These company drones are really only meant for delivering information gathering. Our systems and drones are meant for more than that, being able to extract people from dangerous situations and emphasizes communication.
So in conclusion, our drones are inexpensive, rapidly deployable, standalone search and rescue systems to combat and provide a solution.
Thank you.